Okay, hi, so this is the second video on electrolysis, and the reason I've decided to split this up into more than one video is that there are various different terms that you need to know and different theory which you haven't seen before when you were younger. And so therefore, putting all of it in one video just might be a bit overwhelming. So I decided to split it up, and it makes sense. So, in the last video, you looked at the electrolysis of molten salts. So we did lead iodide and we also did sodium chloride. Now, the problem with that is that if you'll remember, I said you've got to heat them to a really high temperature to melt them down. That's because ionic solids have very high melting points because they're very strong. They've got lots of ionic bonds inside them, and so therefore it's hard to break them down. Now, it would be a bit of a pain if the only time we could ever do electrolysis was at ridiculously high temperature. And so therefore, there is another way around it. And you'll remember that sodium chloride, or table salt, is easily soluble in water. So we can easily dissolve sodium chloride in water. And if we can do that, then we have already separated the ions. Because when we dissolve a salt, the ions have actually separated because we've broken down the ionic bonds. And so then we can carry out electrolysis using a solution rather than using the molten compound. So, I'm not going to use sodium chloride because there is a problem with this. But the equation that you're given in your textbooks, so the example you're given, is copper bromide. And copper bromide, just as if it was molten, is broken down into copper and bromine. Bromine is Br2 and copper is just Cu. So this is all balanced. Okay, now we're not going to do this at a massively high temperature because we just dissolve the copper bromide. And remember, if something's dissolved, it's not liquid, it is aqueous is the symbol we give it. Aqueous meaning dissolved in water. Now we are going to produce pure copper. Pure copper is not soluble because if we put a strip of copper metal in water, it doesn't dissolve. Pure copper is a solid metal. And so this is the difference here. Because it's not a high temperature, it's not a liquid, it's a solid. The bromine is not a gas because we're not doing this at a really high temperature. And so the bromine is given off as bromine, but bromine is actually a liquid at room temperature. And if it's a liquid dissolved in water, it's given the aqueous symbol as well. And so you've got to be aware that when we dissolve in water, so we've dissolved in water, sometimes we can produce products which are not what we would expect. So products can be unexpected or difficult to predict. And that is because the water actually messes around, and sometimes water can actually split up and change what's being produced at each electrode. But in this case, it behaves quite well, which is why this is used as an example. So let's draw it out. If we have a beaker, like so, we're going to have our electrodes in there. So our electrodes, like so, they're going to be joined up with a power source in between. Power source, here we go. This is the negative electrode, this is the positive electrode. And we don't have a molten compound here. We have a copper bromide solution. And copper bromide solution is going to be this blue colour. Like this. So you've got this copper bromide solution. In there is copper bromide, which is broken down into its ions. Okay, so what's going to happen is our copper, let's do copper in red. Copper produces copper ions, like so. The copper ions, just as we saw in the last video, opposites attract positive to the negative electrode. How about the bromines? Well, exactly as before, bromine forms negative ions, and that is going to go opposites attract to the positive electrode. Bromine will give away electrons, and electrons will travel this way, and they'll go all the way around, and they'll travel into here. So you have electrons in here, and those electrons are going to be taken up by the copper, and so here we're going to produce bromine, But remember, the bromine here is in solution. It's not gaseous bromine. We've got bromine just forming in solution. And on the negative electrode, sorry, that's on the positive electrode. On the negative electrode, we are going to get copper metal. And the copper metal is a solid, and it will just be formed on the surface of your electrode, like so. So your copper has actually coated your electrode, because when it forms here, it's a solid. It's not going to drip down, because that's what liquids do. It's a solid, it will just stay where it is. So we've got bromine here and copper here. So copper metal. Okay? So it's not really too different from the molten examples. You've just got to remember those state symbols where we write aqueous, like here. We write aqueous because it's dissolved in water. And the copper is going to form a metal and stay on the surface of the electrode. It's not going to be up here because the solution, which is here obviously in blue, doesn't reach up the top. So it's going to coat only where it can touch the metal, like that. Okay. Now there is a way that we can write down in equation form exactly what's going on at each electrode. And this is known as using half equations. But first off, there are two terms you need to know, which are oxidation and reduction. Okay, now you've probably seen these terms before. Well, you definitely have. And you've probably seen them in the sense of oxygen. So oxidation is the addition of oxygen and reduction is the removal of oxygen. Now, when you move forward and you start talking about electrons, we use the same terms, oxidation and reduction, but oxidation is the loss of electrons. The loss of electrons. Okay? Not the gain, the loss. And reduction is the gain of electrons. And a lot of the time that really does confuse people, but think of it like this. An electron is negatively charged, and therefore if we gain electrons, we are going to reduce the charge because they are negative. If you gain an electron, you become negatively charged, so your charge has gone down. Okay? So reducing the charge as a result of the gain of electrons. The opposite is oxidation, and that is the loss of electrons. So that is when your charge will go up or become more positive. Okay, and so in an electrolysis, we are going to have an oxidation occur at one half and a reduction occur at the other. So at one electrode, we're going to have an oxidation, and that is going to be at your positive electrode. Because if we have a look up here, on the left-hand side, our positive electrode is where bromine is going to give away an electrons. So oxidation is loss of electrons. Bromine has lost its electrons. And on the other side, the negative electrode is where reduction is going to occur because copper is going to gain electrons, and that's reduction. Okay, now half equations are written like so. We use ions and electrons in half equations, and I'm going to talk about the left-hand side first, so the oxidation. If you have bromine and your bromide ion, what you're starting from is the bromide. So we're going to write that out first. Br minus. So Br minus is going to form Br2 because that is your bromine, molecular bromine. So bromine minus is going to form Br2. How did it form that? Well, it also gave away its electron. Like so. You'll notice these aren't balanced. To form Br2, you need two bromides. So two of those. Each one of those gives away one electron, and so you need two electrons as well. And this is your balanced oxidation half equation. Okay, in your book you'll see that you could also write it like this. Minus electrons leads just to bromine. Now I really don't like this. It's not technically correct. If you go on further to do chemistry, this is just not correct. In terms of equations, we always use addition signs. So please, if you can, avoid using the bottom one. But if you do use it, a lot of the time you'll be given the mark anyway. Okay, but do try and use this because it's more correct. Right, now on the other side, we have our reduction. So our reduction of copper. Do that in a different colour. So we have copper, which we're starting with, Cu2+, okay? That is going to form copper metal, okay? How does it form copper metal? Well, the Cu2+ is accepting electrons. So at this electrode, it's accepting the electrons from the negative electrode. So it's gaining electrons, and that's why it is a reduction. And to balance the charge, we have 2+, and so we need to bring that down with 2 electrons. So 2 electrons. And if you notice, that's important because we have 2 electrons up here. So here we can see why we're going to have 2 electrons down here. And so that will form your copper, and this is balanced. Cu2+, 2 electrons makes copper. Okay, one thing to mention, a handy way of working out, remembering what oxidation and reduction are, is just remember the word oil rig. Oil rig, oxidation is loss, reduction is gain. Oxidation is loss of electrons, reduction is gain of electrons. So that's just a quick way which you can remember that. Now lastly, you'll remember I said that when we have aqueous solutions, so solutions in water, and electrolysis occurs there, sometimes the water can take precedence over anything else we have there. So the water will actually interfere with what we're producing. Now there is a way of actually predicting what's going to happen, and we're going to look at the separate electrodes individually. So let's say first at the negative electrode. At the negative electrode. Right, now at the negative electrode, let's just go back up to the diagram. Negative electrode, that is where, that's on your right hand side, that is where your positive metal ions are going to go. So always your positive ions are going to travel towards the negative electrode. And almost always they are going to be metal ions. Okay, so it's going to be metal ions which are travelling towards there. Now, if you're carrying this out in water, let's do this in a different colour. H2O actually breaks down, you don't need to remember this small part, into H plus OH minus. Okay, and so we have hydrogen and hydroxide. Now hydrogen, this is what you do need to remember, hydrogen also travels towards the negative electrode because if you can see, it's also positively charged. So we have metal ions and hydrogen. Hydrogen. Okay, I'll get rid of that just to neaten things up. So we have metal ions and hydrogen both going to the negative electrode. And so how do we know which one is produced, either the metal or hydrogen? It comes down to reactivity. Let's say that we have this electrode here. This is a negative electrode. So negative electrode. And we have H plus, and we also have sodium. Sodium plus. Both of these guys want to travel towards the negative electrode. So both of them want to go this way. But which one is going to get the electrons from the negative electrode? Well, it obviously depends on reactivity, and in general the less reactive is going to win. So the more reactive stays in solution. And so if you can remember, sodium and potassium are pretty much the most reactive metals that you'll come across. They are both more reactive than hydrogen. So sodium, because it's so reactive, is happy staying in solution as an ion. Because it's so reactive, it will just buzz around and it's happy. Whereas hydrogen is less reactive. It actually wants to become hydrogen gas and be stable. It wants to settle down and be stable in that sense. So hydrogen will win in this case, and we will form hydrogen gas. And so at this electrode, we will get hydrogen gas bubbling off. And so obviously hydrogen gas is not blue, but we'll get hydrogen gas. So H2 gas. Okay? This is of course very different to what we saw in the example above with copper. because copper is a very unreactive metal. Copper is less reactive than hydrogen, and so hydrogen is more happy buzzing around as an ion. Copper just wants to be out of the situation and just become copper metal, and that's exactly what it does. It becomes copper metal here, and so we form the metal on the electrode. Okay, right. Now how about what happens at the positive electrode? So at the positive electrode. Positive electrode. Okay. Well, at the positive electrode, if we look up here, oh no, I crossed it out, didn't I? So remember, I said that H2O will break down into H plus OH minus. Okay, H plus obviously is attracted to the negative, and that means that OH minus is attracted to the positive. OH minus is hydroxide. Hydroxide. This hydroxide is attracted to the positive electrode, and so we will have hydroxide attracted to the positive electrode. And hydroxide, when it gets to the positive electrode, will form oxygen gas. Oxygen gas. Okay, but if we go back to our example up here, what did we actually form at the positive electrode? We formed bromine, not oxygen gas. There will be hydroxides in solution and H pluses in solution buzzing around from water, but we had bromine form here. And so why was that? Well, that's because if you have a halogen just means group 7. So that's fluorine. Well, we don't really speak about fluorine, but it does include fluorine. If you had chlorine, bromine, iodine, they will form as well at the positive electrode. And so in general, these guys will form. So if you have a group 7, so a salt which has got group 7, these guys will form. So halogen comes first. Then the next one is oxygen gas from your hydroxide. So oxygen gas. And after that, you'll have any other negative ion. Any other negative ion. So if you had a different negative ion, then they could form, but oxygen gas is more likely to form. And if you've got fluorine or chlorine or bromine or iodine, they are even more likely to form than the oxygen gas from the hydroxide. So they're the rules you need to remember. You don't need to know specifically why this occurs. Obviously with the negative electrode, you need to know it's due to the reactivity. But with the positive electrode, just learn these rules and you'll be okay. Right, so I think I'll stop there. We're going to go through some examples in another video, but I hope this has helped clear things up about what happens in solution and how we write down half equations. If you do have any questions on any of that, then please do send me an email or write a comment in the box below, and I look forward to seeing you in the next video.